so now after that, we have to add the final triangle, which is plus this into half into base, which we know is 5 seconds, to height, which is v. Okay. Right. So let's just keep solving this. So half into 20, we have get a 150. Half into 20 into this. Half into 10 into 20, 100. So 1/3 over this 100 plus half into 5/2 v plus 20 plus 27.5 v plus 5/2 v. Okay, so to solve this even more, so first 150, let's just multiply this 450 equals to 100 plus 5/2 v plus 5/2 to 20 is 50 plus 27.5 v plus 5/2 v. So now we just solve for v, which we get as 12. Okay, so 12 is your final answer if you solve all this. Right, moving on to question number 4. Okay, then again the graph is given here as well. An elevator moves vertically, supported by a cable. The diagram shows a velocity time graph in which it models the motion of the elevator. The graph consists of 7 straight line segments. Okay, so the elevator accelerates upwards from rest with a speed of 2 over a period of 1.5 seconds and travels at a speed for 4.5 seconds before decelerating to rest over a period of 1 second. Okay, the elevator then remains at rest for 6 seconds before accelerating to a speed of v downwards over a period of 2 seconds. The elevator travels at this speed for a period of 5 seconds before decelerating to a rest over a period of 1.5 seconds. Okay, find the acceleration of the elevator during the first 1.5 seconds. Very simple. So acceleration is final velocity, which is 2 minus initial 0.5, which we get as 4/3 ms. So just write it in exact form. And yeah, that's it. Now, question number B. Given that the elevator starts and finishes its journey on the ground floor, find V. Okay. So what this means is that it starts over here, okay, travels at constant speed and decelerates over here. So it ends one time over here. And then it goes over here again and it ends over here. So these two journeys over here, 1 and 2, they travel the same distances. So this whole distance is equal to this whole distance. That's what this question is saying. Right. So in that case, let's find the area of this. So this is a trapezium, and this is also a trapezium. So half into this side is 7 plus, wait a second, this is both trapezium. Yeah, plus 2 to the height. Wait, this is 7. This part is 4.5, my bad. Five into the height, which is 2. This is equals to half into 13 minus 21.5, which is... Okay, yeah, that is 8.5. So 8.5 plus this part, which is 5, to the height, which is v. Okay, great. So now we solve this. Hopefully we can find the value of v. Over here we get 11.5 equals to half into 8.5 plus 5. 6.75 v. Wait, I think I made a mistake. It's not supposed to be like this. Hold up. Okay, v we get is 1.70. Okay, yeah, it's correct. Never mind. 3SF. Always rounded off to 3 significant figures. Now, question number 5. Two cyclists, Isabel and Maria, are having a race. Okay. They both travel along a straight line road with a constant acceleration starting from rest at point A. Isabel accelerates for 5 seconds. Okay. Isabel accelerates for 5 seconds at constant speed of this. She travels at a constant speed. She has reached for 10 seconds or decelerating during the rest at a constant speed of 5 seconds. Maria accelerates at a constant rate, reaching a speed of 5 at a distance of 20. Okay. Alright. Okay, she then maintains the speed for a period of 10 seconds, or deciding to rest at a constant speed of a period of 5 seconds. So the best way to solve this question is actually drawing the velocity time graph of each person. So let's start off with Isabel. Oh wait, what the hell am I doing here? There we go, Isabel. And over here we can draw for Maria. Okay. So velocity. It's always good to draw velocity time graphs, and that really helps to understand the question. So Isabel accelerates for 5 seconds. Okay. So Isabel accelerates for 5 seconds. Travels at constant speed. Okay. For decelerates and coming to rest. Alright. What about Maria? Okay, she also accelerates. Okay. Maintains speed, constant speed, and then decelerates. Okay. Let's label this a bit. Accelerates for 5 seconds. So this is 5. This acceleration is A. We don't know this, we can write this as V. Travels constant speed for 10 seconds. So this part is 5 plus 10, 15. Constant further 5 seconds. So 20. What about Maria? She's speed of, okay. Distance is 27.5. She then maintains speed for 10 seconds. So this part is 10 seconds. For decelerating constant speed of a period of 5. So this is 10 and this part is 5. Okay. Now, it says, given that acceleration is 1.1. Is 1.1. Find which cyclist travels further. So we need to find the distance of both and see which distance is longer. So which area under the graph is larger. So first let's start from Maria. So we know the acceleration. We just don't know the final velocity, which we can find real quick. So final velocity is gonna be 5.5. So over here, this is actually 5.5. So now we can just plug in the values. 10 plus 20 into 5.5. So what do we get here? We get 82.5 meters. What about Maria? So this part is going to be also this part with distance we already know. What about the rest? The base is 10. Wait, rectangle. So 10 into 5. This part plus this part plus this part. 5. So 10 into 5 plus into base to height 27.5. So let me add these values. We get 90. As you guys can see, Maria has a larger area, hence Maria goes further. Answer. Now, find the value of A for which the two cyclists travel the same distance. I mean, these two areas the same. Okay. So, since we don't know the acceleration, we cannot write this as anything. Right, so this is going to be A. Oh, I mean, this is going to be V, and this is going to be A. Rest is pretty similar. I erased a few things, hold up. Okay. Alright, so this is A. That means so this distance from Maria won't change, right? So 90 will remain as it is, but over here acceleration will be this velocity, and the time will still be actually, yeah, it'll still be 5. Okay, nice. What is V then? V is equals to 5A. So let's consider this as 5A. So everything else will be the same. So half into 10 plus 20 into 5A. Right. So now I just have to solve for A, and so if we solve for A, we get A equals to 1.2, which is the answer. Nice. Now moving on to the next question. Question number 6. A bus moves from rest with constant acceleration 12 seconds, then moves with a constant speed of 30 seconds before decelerating uniformly to a rest of further 6 seconds. The total distance traveled is 585 meters. Find the constant speed of the bus. Okay, so let's draw a rough sketch. So it turns from rest, okay, moves with constant speed, and then decelerates uniformly. Great. Okay, so it moves from rest with a constant acceleration 12 seconds. 12, then moves with a constant speed for 30 seconds. 42, and then 40 so uniformly the rest of 36. Okay, so this is 48. Okay, so half to base. So you can just use a trapezium, that's better. 48 plus 30, the height is V is 585. Half into 48 plus 30. 39V is 585. V is by 39, which is 15. Okay. So the constant speed is 15. Alright. Great. Now, find the magnitude of the deceleration. So what is the magnitude of the deceleration? So acceleration equals to 0 minus 15 by 6. Whenever it says magnitude of something, you don't really have to give the like you can give the sign negative, but you can also write as just 2.5. Since it only asks for the magnitude, I'm only gonna write 2.5. If it says like find the deceleration, then only then just put the negative sign over here. But over here, this doesn't really ask for that, hence the answer is only 2.5. Now for question number 7, it's gonna be the last question. The diagram shows a velocity time graph which models the motion of a car. The graph consists of 6 straight line segments. The car accelerates from rest to a speed of 20 meters per second over a period of 5 seconds, then travels at this speed for a further 20 seconds. The car then decelerates to a speed of 6 meters per second over a period of 5 seconds. The speed is maintained for a further t minus 30 seconds. The car then accelerates again to a speed of 20 meters per second over a period of 50 minus t seconds before decelerating to rest over a period of 10 seconds. Okay, so the graph is given. Given that during the 2 stages of the motion when the car is accelerating, the accelerations are equal. Okay, so that means this acceleration and this acceleration are equal. So find the value of t. Alright. How can we find the value of t? It's 5 seconds, 25, 30, 30 minus t. Okay. So I have to use simultaneous, I think. So what is this acceleration? Acceleration over here is initial minus final by 5 is 4. That means 4 over here the same. This is also 4. 4 equals to final minus initial with a time, which is 50 minus t. But now let's just solve for t, and we get 46.5. Nice. That is your answer. Great. Now moving on to part B. Find the total distance traveled by the car during the motion. Okay, this whole motion. Okay. So distance equals to, first part is triangle, and then you can just use a trapezium. And then a rectangle. Then we have trapezium again. And then finally a triangle. Okay. It's pretty big, but very simple. Just now input all of this in your calculator. And that should be it. Now the value of t we know is 46.5. So we can just write 46.5. And over here, 46.5 And where else? Okay, yeah. Input this in the calculator, and you should get 759.5 meters, which is your answer. Alright, so that's gonna be it. We just did a couple of past paper questions. There are more questions of this, of course, but like if you guys can do all 7 of these, and probably got a list. If you guys want this topical question paper that I'm solving, then if you want to solve the rest of your questions yourself, then make sure to, I'll put this in the description actually, and over there you can find this, and then just keep solving all of them, right? That's gonna be it for this video. If you guys want any explanation of the video, if you're struggling with any of the other questions, since there are 25 questions, I think 24 or 25, I only still solve 7 of them. If you have any other problems with this paper, make sure to comment down below. I will explain as the best I can. It's gonna be this video, and goodbye. Thank you.